Advanced Algebra, Chapter 13, Lesson 2, and again, this video is a introduction or a review of the 30, 60, 90 and the 45, 45, 90 triangles that we studied last year in geometry. And again, this video, along with the previous video, is going to lay the foundation for what we're going to be doing with these trigonometric ratios over the coming lesson. So again, it is introduced as a pre-calculus video, but this is for Advanced Algebra, Chapter 13, Lesson 2, a review of special right triangles. Chapter 4, Lesson 2 of Pre-Calculus, and I wanted to do some review with these right triangles quickly before we looked at then using or determining the trigonometric function. You remember in a right triangle we have the right angle. The hypotenuse is always opposite of the right angle. The other two sides we'll call the legs. And we had two special right triangles that we talked about in geometry. You introduce those in geometry, and that's called a 45, 45, 90, and there's some special relationships in the 45, 45, 90. We're going to make this length 1 and this length 1, and in a 45, 45, 90 you should remember the legs are the exact same length. If we apply the Pythagorean theorem, a squared plus b squared is equal to c squared, we have 1 squared plus 1 squared is equal to c squared. We simplify that, we come up with the square root of 2. So in any 45, 45, 90 triangle, the legs are going to be the same, and then the hypotenuse is always going to be radical 2 times whatever those legs are. And hopefully you remember that little equation. The hypotenuse in a 45, 45, 90 triangle is always the leg, whatever it is, times the square root of 2. So in this case, the lengths are 1, so this is 1 times the square root of 2, which would be the square root of 2. Now this is going to be very important, as remembering that this is 1 and 1, and then we just simply multiply it by the square root of 2. Okay, I've said that like 3 times. I'm hoping you're going to remember that the hypotenuse is the leg, whatever it is, times square root of 2. So if this was 2, this one would have to be 2, because in a 45, 45, 90 they're always the same, and this would have to be radical 2 times that, or 2 radical 2. So if my legs were 8 and 8, then what would the hypotenuse be? 8 square root of 2. If my legs were 10 and 10, what would the hypotenuse be? 10 square root of 2. Okay, so it's very important that you remember that ratio. Alright, let's look at the other special triangle we had. The other special triangle that we had was the 30, 60, 90 triangle. We still have our 90-degree triangle, so we still have our hypotenuse, but now these angles are different measures, so the sides are different measure. And if you remember from geometry, the longer side is opposite the bigger angle. So 60 is larger than 30, so the side that's opposite 60 is longer than the side that's opposite 30. So this is what we call the shorter leg then, and then this one would be the longer of the two legs. Now there is a special relationship amongst here as well. If we made the shorter leg 1, let's make that the smallest, the longer leg is always going to be radical 3 times the shorter leg. So this is going to be radical 3 times the shorter leg. And the hypotenuse is always going to be 2 times the shorter leg. So if this is a 1, if the length of this is 1, then this would be radical 3 times 1, which is radical 3. This would be 2 times 1, which is 2. So it's very important to remember these two relationships, that in a 30, 60, 90, the hypotenuse is always 2 times the shorter. Okay? And the longer of the two legs is always 2 times, not 2 times, excuse me, but radical 3 times the shorter. Notice both of those are related to the shorter. So the shorter, I can get that. Alright, and then you understand that the opposite or the inverse was true if you knew one or the other. I don't know if that made any sense. I don't know. It didn't make much sense to me, so just forget it. I'm going to go on. So if this is 4, what would the longer leg be? 4 times radical 3, because the longer leg is radical 3 times it. What would the hypotenuse be? Twice this, which would be 8. Alright, so if my shorter leg was 12, what would the longer leg be? Well, radical 3 times that, 12 radical 3, the hypotenuse would be 12 times 2, which would be 24. So these relationships are very important when we come to doing trigonometry, and again, you must know these, all right? You must know these. So in a 30, 60, 90, the longer leg is always radical 3 times the shorter, and then the hypotenuse is always twice the shorter. So that's the review of the 30, 60, 90 and the 45, 45, 90. So it's very important that you know those relationships. In the next video, we'll look then at using these triangles in that coordinate plane or on the unit circle, and using what we call reference triangles in order to help us figure out the trigonometric ratios.